Hey guys, so I did not forget about the 8th graders, but here is the last video today of me reading the blizzard bag packet to you guys that you picked up on Monday. You guys have the packet that has like the female scientist on the cover of it. The essential question is, how do authors use language and text structure to express their points of view? So I think I'm only reading 6 pages of this today, and then you guys will work on the questions on your own. If you guys have watched the other 2 videos, I said that I normally do my live stream on Wednesdays, so if you guys have questions about the packets, that would be the time to ask for help, and I'll go over it. You guys are responsible for the questions that are kind of on the side of the pages. For example, on page 168, which is the first page, it has a little heading that says Cite Evidence. You guys will still have to do those if you want to receive full credit for doing your packet. Again, if you guys have questions, you can either wait till Wednesday to ask me. I think Mr. Murray is doing Thursdays. And then you can always email me. You guys or your parents picked up a packet that had everyone's emails in it. So you have access to that as well. We also have set up a Google Classroom. So far, only Alex and Devin have joined the classroom, so shout out to you guys. I will be posting the Google Classroom invite code as like the thumbnail for this video and in the comments, so you guys will have it. Please join, because we don't want you guys to stop reading To Kill a Mockingbird just because of all this weird stuff happening. Okay. So here we go. Near-Earth objects. Imagine that you are standing outside your home looking up at the morning sky. Suddenly, the sky fills with an exploding ball of fire. Rapid waves of thunderous noise batter your ears. The ground shakes violently beneath you. When you finally regain your composure, you see that miles of trees and grass in the distance have been burnt away. It is as though Phaeton's doomed fury chariot from ancient Greek myth has passed by. The people living near the Podkanaya Tunguska River in Russia in 1908 did not have to imagine this scenario. They experienced it themselves. On June 20th at 7:17 a.m., an enormous fiery object from outer space burst through Earth's atmosphere and exploded. The energy released by the explosion was so great that seismologists as far away as England recorded seismic waves as powerful as those produced by a strong earthquake. Survivors later recalled a fire that was as intensely bright as the sun. As burning trees splintered and fell from the heat and flames, smoke as thick as fog started to cover everything. Scientists thought the ball of fire may have been an asteroid or a comet. However, they have recently found evidence that suggests it may have been a meteorite. The Tunguska event, as it was labeled, remains one of the most famous of all impact events. But it was not the last. Today, scientists around the world study the potential for future impact events, trying to figure out ways to prevent such catastrophes. Impact events. It can seem like planet Earth, our sun, our moon, and the stars are the only objects in space, but there are hundreds of millions of astronomical objects. Sometimes these objects will collide with each other. In fact, every day, microscopically tiny objects from outer space gently collide with Earth. These tiny objects are called cosmic dust. Cosmic dust is not the kind of dust that gathers on furniture in your home. In fact, you cannot see cosmic dust at all, but scientists estimate that anywhere from 11,000 to 661,000 pounds of cosmic dust land on Earth every day. Of course, this gentle dusting has no serious or even noticeable effects on Earth. However, if the effects of a collision are measurable, such as ground-shaking Tunguska event, then the collision is considered to be an impact event. An impact event involving Earth could result in physical changes to our planet, such as miles-wide crater being blasted into its surface. It can also have consequences for our biosphere, such as causing animals to die and filling our atmosphere with gases and dirt. A planet-sized body colliding with Earth would be like a gigantic wrecking ball smashing into a building. It would destroy the planet. But scientists have calculated that the probability of a Earth or similar large body crashing into Earth is incredibly slim. They also say that it could not possibly happen until billions of years into the future. Near-Earth objects. Some asteroids and comets, however, do present a more immediate threat to Earth. The potential danger is so great that the National Aeronautics and Space Administration, NASA, has a program to identify and track these possible threats. The program is called the Near-Earth Objects Program. The scientists working in the program look for and track asteroids and comets that travel in an orbit that gives them a perihelion distance Q less than 1.3 AU. According to the program's website, AU means astronomical unit, and 1 AU is Earth's distance from the Sun. Scientists are looking for objects that at their closest points to Earth during their orbit are less than 1.3 astronomical units, 194.5 million kilometers, or 120 million miles away from the Sun. That may seem like a long distance, but in terms of space, it is not. NASA scientists are particularly concerned about objects with an orbit that will eventually place them within 45 million kilometers, or 28 million miles, of Earth. If an asteroid or comet came that close to Earth, then Earth's gravitational force could pull it toward us, creating an impact event. These asteroids and comets are labeled near-Earth objects. Asteroids and comets that are not traveling on a path that could bring them close to Earth are not given this designation. Near-Earth objects are the focus of much scientific observation and study. On June 18, 2013, NASA detected the 10,000th near-Earth object, an asteroid that has been named Asteroid 2013 MZ5. By late summer of 2013, NASA had identified close to 70 near-Earth objects. Asteroids. What exactly is an asteroid? Asteroids, like all objects in our solar system, orbit the Sun. Some asteroids are made of metal, such as iron and nickel, but most asteroids consist of rock and minerals. Some asteroids are spherical, like planets, but most are irregularly shaped. Asteroids can range in diameter from a few feet to several hundred miles. The largest asteroids are sometimes just called planetoids. Comets. A comet is made up of ice, pieces of rock, and dust. The ice holds the pieces of rock and dust together. Comets follow an elongated elliptical orbit. This orbit takes them far away from the Sun and even far past the orbits of the outermost planets in our solar system. The orbit also brings comets close to the Sun. When it does, the heat from the Sun can melt the ice. This causes dust and gases to trail behind the comet like a tail. An astronomer invented a popular term for comets, dirty snowballs. The average comet has a diameter of 10 kilometers or 6 miles or less. Meteoroids, meteors, and meteorites. People often use the terms meteoroid, meteor, and meteorite interchangeably. However, the terms do not have precisely the same meanings. A meteoroid is a space rock much smaller than an asteroid or comet. Most meteoroids have a diameter of no more than 10 feet or no more than 10 meters or 33 feet. Some are chunks of rock that have fallen loose from a comet heated by the Sun. Other meteoroids are bits of an asteroid that broke off when two or more asteroids collided into each other. Some meteoroids are even leftover material from the formation of our solar system billions of years ago. Meteoroids often crash through Earth's atmosphere. Most of them burn up from the friction of passing through our atmosphere before they hit the ground. The light from their burning creates a bright streak in the sky. That streak is what we call a meteor, or more poetically, a shooting star. Since a star is an enormous plasma sphere, such as our own Sun, you can see that the popular term is not scientifically accurate. If you carefully watch the nighttime sky, you might see several single meteors in just a single hour. Sometimes a group of meteors flashes across the sky. That is called a meteor shower. If a meteoroid does not completely burn up as it passes through our atmosphere, it will fall to the ground. Once it lands, it is called a meteorite. Though most meteorites are no bigger than a pebble, some weigh tons. The largest meteorite found so far weighs 66 metric tons, about 145,504 pounds. There is no known modern-day instance of a meteorite killing anyone. But in 1954, Elizabeth Hodges got the surprise of her life. An 8.5-pound meteorite crashed through her roof, bounced off her radio, and hit her on the hip. Miraculously, the space rock did not break her hip bone or do worse damage. Greater threats. NASA analyzes meteor showers and meteorites, but NASA's Near-Earth Object Program does not track meteoroids. The program monitors only near-Earth asteroids and comets, which pose a greater threat to humanity than damaged rooftops and bruised hips. NASA has been particularly focused on objects with a diameter of 1 kilometer, 0.62 miles, or larger. An asteroid of that size could plausibly end civilization, according to John Holdren, a White House science advisor. But now NASA is turning its attention to smaller asteroids as well. That's because the impact caused by an asteroid with a diameter of just 50 meters or 165 feet could destroy a city. Tracking threats. To identify and track threats, NASA uses powerful telescopes that can peer deep into space. If an object appears to be a threat, NASA will observe the object and collect data to determine its orbit. NASA determines an object's orbit by identifying its location in space at the moment of discovery, observing where it is located after a period of time has passed, using data related to the change in location to make a prediction about where the object will be after additional time has passed, checking to verify whether the prediction was correct. Once a potentially dangerous object is identified, NASA continues to observe it and refine its predictions based on each new set of verified data about the object's orbit. NASA checks some asteroids and comets on a daily basis. Others are checked on a weekly basis. When refining its predictions, NASA considers the effects of the gravitational forces of the Sun, the planets, including Earth, and our Moon on the object. NASA also considers the likelihood that another object may collide with the object being tracked, which would affect its orbit. In addition, NASA considers the effect of sunlight. Sunlight heats up the side of the object it hits. As the object rotates, it radiates heat back into the atmosphere on the side not facing the sun. The closer the object comes to the sun, the more sunlight it receives and radiates. This can affect the object's orbit. This effect is named the Yarkovsky effect after Ivan Yarkovsky, a civil engineer who came up with the theory in 1888. So that is the end of the reading. We ended on page 173, where there's 5 questions you guys have to answer at the end. Like I said earlier, these questions I'll be going over more so during my live stream. Or if you guys have questions now, you can always email me.